In this video, we are going to talk about function notation and how to apply function operations. Function notation is the way a function is written. It is a way that we can distinguish different types of functions. For example, if you are in a classroom and everyone's name is Emma, it's hard to distinguish who the teacher is talking to. So when we're talking about functions, they are given a letter name. This right here is the name of the function. We pronounce it f of x, or g of x, or h of x. Then on the other side of the equal sign is what it does. So this function f of x is saying that we take 3 and multiply it by x and then add 1. What we do with functions, we can do several things. One, we can evaluate functions. So in example A, it is telling us that we are going to take function f and we want f of 2. So where there's an x in function f of x, we are going to replace that x with a 2. So the first thing we do to begin is we're going to write the function, but instead of writing an x, we are going to do parentheses. Then inside those parentheses, we're going to put what is in these parentheses right here. For this example, it's a 2. Then we just solve this problem. 7 times 2 is 14, and then we add the minus 3. 14 minus 3 is 11, and that is how we solve that equation. Let me show you another example on C using function k. Function k is the square root of x plus 3, and where there's an x, I'm going to write parentheses. This example C wants k of 6, so I would put a 6 in those parentheses. When I simplify 6 plus 3, I get 9, and the square root of 9 is 3. And that is how you simplify those functions. Example E and F are slightly different. We're going to look at example F right now. So in example F, we are using function f just like we've used in example A. So I'm going to still write the 7 and a parentheses, leaving slightly more room because there are more terms in the parentheses in our f of x plus 1. And then I'm going to add the negative 3 because that is all part of the function called f of x. In the parentheses, I'm going to put x plus 1 this time. Then I'm going to distribute the 7 to each of the terms inside the parentheses, giving my answer as 7x plus 7, and then I still have minus 3. Plus 7 minus 3 are like terms which I can combine to get 7x plus 4. And that is how you evaluate functions. The next thing we are going to look at is function operations. Functions can be added, subtracted, and multiplied. Those are the operations that we're going to be talking about in this video. In example A, we are going to consider the function f of x being 2x plus 4, g of x being x minus 1, and eventually we're going to use h of x, which is x squared. In example A, it's asking me for f minus g of x. So we are going to leave these functions in terms of x. So f of x is 2x plus 4, and then we're going to subtract g of x, which is x minus 1. Just like when we previously combined polynomials, we're going to look for like terms and do what the operation says. So 2x minus x is x, and 4 minus negative 1 is going to end up with being 4 plus 1, which is 5. The solution to example A is x plus 5. Example B asks us to take function f and add it to h, and we want that still of x, so in terms of x. So I'm going to take function f, which is again 2x plus 4, and add it to function h, which is x squared. And in these two polynomials, there are not like terms, so all I need to do to finish solving for this equation is to write all of my terms in standard form. Then we're going to come down and look at example D. In example D, it's asking us to take function g and multiply it by function f. Function g is x minus 1. Function h is x squared, and it wants us to leave it in terms of x. I like to use the box method to distribute, and that's what I'm going to use here. Oh, you know what? Sorry, let me draw my box the other way. Here we go. We're going to do the box method this way. On the left, I have x and a -1, and on top, I'm going to write x squared. X times x squared is x cubed. -1 times x squared is -x squared. So the answer to example D is x cubed minus x squared. Then we're going to solve all the way down, and we're going to look at, oh, you know what, we want to do example J, but instead of doing f of x, what we're going to do is f of 2. So what this means is that we are going to evaluate the function f at 2, and then we're going to multiply those two functions by each other. So if I wrote it out in terms of x, I would have 2x plus 4, which is what function f is, and then I would multiply it by 2x plus 4. Well, when we evaluate that at 2, we're going to remove the x and put a 2. And then we're going to do the same thing on the other side. 2 times 2 is 4. Then we still have plus 4, and then it's still 4. When I add these two, 4 plus 4 for both of these is 8. And 8 times 8 is 64. And that is how you evaluate functions.